Today we learn EMF equation of DC machine. EMF equation of a DC generator. Here the DC machine is considered as DC generator. As we know, armature rotates and voltage is generated in the armature winding. In case of a generator, this generated EMF is called generated EMF or armature EMF, and this EMF is denoted by EG, G for generated. In case of the motor, when the DC machine working as a motor, the EMF generated due to rotation is called back EMF or counter EMF, and in this case the EMF is determined or denoted by EB, that is back EMF. The expression of EMF in case of a DC motor and DC generator are same. Let's consider a DC machine. Number of pole is P. Phi is the flux per pole in over. Total number of armature conductors is the speed of armature in RPM, that is revolution per minute. It is not in second, it is in minute. Revolution in 1 minute. A is the number of parallel paths in the armature winding. In one revolution, that is in complete revolution, the flux cut by an armature conductor is given by P, that is the number of pole, and flux generated by each pole, that is phi. So in one revolution, flux cut by one conductor is given by P into phi. Time taken for one revolution is equal to n by 60 seconds. We know n is revolution in 1 minute, that is revolution in 60 seconds. So in one revolution it will take n by 60 seconds. According to Faraday's law of electromagnetic induction, generated EMF is given by total flux cut by total time taken. P phi is the total flux cut by one conductor, and time taken for one revolution is n by 60. So P n phi by 60. We know number of parallel paths in armature winding is A. Hence, in each path, number of conductor is Z by A, where Z is the total number of armature conductors. Now, generated EMF EG is given by P n phi by 60 into Z by A in volt. Or generated EMF in simplified form P n phi into Z by 60 A. This EG is called generated EMF in DC. Same thing in case of DC motor is called EB or back EMF of the motor.